Logit model is very similar to the probit model. The difference between the logit and probit is that the right-hand side of the logit model is given by the CDF of a logistic distribution, evaluated at beta naught plus beta 1 times x. Relative to the probit model, the logit model is numerically convenient, because now you can plug in any value of z in the exponential function and compute the result of a logistic CDF function very easily. It's much harder to compute the result of a standard normal CDF function given a z-score. In practice, however, the fit of a logit model is extremely comparable to a probit model. Let me quickly show you the difference between a normal distribution and a logistic distribution. In this plot, the Gaussian distribution, or normal distribution, is shown in the dotted line, and the logistic distribution is shown in the solid line. Relative to the normal distribution, the logistic distribution is characterized by a higher peak and fatter tails. In other words, the logistic distribution is more leptokurtic than the normal distribution. Other than that, they are very similar to each other. By converting the PDF to the CDF, you will see that the CDF of the two distributions are very similar. Since the probit model is based on the CDF of a normal distribution, and the logit model is based on the CDF of a logistic distribution, the fit for both logit and probit should be very comparable. If you fit a logit model on the same data, you will see that the fit is very similar to the fit of a probit. The logit model is bounded between 0 and 1 because the result of a logistic CDF is a probability measure. Since the outcome variable is binary, you're still going to use the GLN function to estimate the logit model. The syntax is very similar, except now you don't have to specify anything in the second argument. By default, when family is equal to binomial, the GLN function will evaluate the logit model for you. The regression output of the logit model is shown here. Similar to the probit, you can conduct t-test and f-test on the coefficients, but these coefficients no longer measure the marginal effects of x and y. You will have to evaluate the marginal effect based on a specific value for x. For instance, following the estimates of the first model, you can evaluate the conditional probability of application is denied given black equals to 1, using the logistic CDF function. Then you can evaluate the conditional probability of application denied given black is equal to 0, using the logistic CDF function. The difference between these two gives 19%. This means that a black applicant is 19% more likely to get an application denied than a white applicant. This computation process is manual and tedious. We can use R to estimate the marginal effects for us. Again, we're going to use the Mabina function in the error package to evaluate the marginal effect. The syntax for the Mabina function is exactly the same as before. In this case, we set the x-mean is equal to true to use the first approach to evaluate the marginal effect. The marginal effect table now shows the marginal effect for each x and y. For instance, the marginal effect of the black dummy in model 1 is equal to 0.191, or 19.1%. This is identical to the marginal effect of the black dummy in the probit model. The marginal effect of PI in model 2 is 0.495. This means that by increasing the PI ratio by 10%, the probability of rejection will increase by 4.95%, holding the black dummy constant. Again, this estimate is very similar to the marginal effect of 5% given by the probit model. To evaluate the marginal effect using the second approach, we set the x-mean equals to false in the Mabina function. Like before, I will show you the marginal effect of black on application denied using a set of trend lines. Similar to before, the dotted line at the top shows the probability of rejection when the black dummy is equal to 1. And the dotted line at the bottom shows the probability of rejection when the black dummy is equal to 0. The difference between these two dotted lines shows that the effect of race on the probability of rejection is persistent across the x-axis. Like before, this plot provides evidence in favor of racial discrimination in mortgage applications. Now let's see how these three probability models compare to one another. The logic fit is captured in the green line, and the probit fit is captured in the red line. The logic fit is associated with slightly higher probability than the probit fit because the logic fit has higher kurtosis. But the two plots are very comparable. The linear model can easily drop out of this plot because it offers the worst fit. Now let's pause this video and do in-class exercise number 4.